So I have a question.
Talk to me. Talk to me.
As our body mass here.
Right.
Body mass here does have
I being real
an
with you.
about form.
I being real with you. I don't know.
You don't know?
I don't know.
I don't
I
know.
I didn't I didn't organize with them. Right. I didn't organize with them. All I know is I will be on campus. If all they want to come and see me, I'll be there. Tevon and I will be there.
I'll be there Thursday.
I'll be there as well.
I bet we linking up. I'll get Tevon to come too. Yeah. But I'm not connected or affiliated with the maths part of UE. I'm not, so I can't really say anything in particular.
Oh, okay.
Yeah. All I know is it'll be in JFK Auditorium. That's why.
Yeah.
Yeah.
Or it's going to be like a secluded part of the campus where everybody had a seat.
No, you all should be able to. Okay, the main thing is in JFK Auditorium. The main thing is there.
Oh, okay.
If you want to go explore other places, I presume that you would have to talk to your teachers and whatnot.
But I come in by myself and I'm going with this school.
Well, don't worry, I'll give you a tour if you want. Give you a tour around UE and thing.
I bet.
Yeah. Alright. I will sign on their shirt and thing too. I'll give all them a signature and thing. Yeah.
Alright.
Yeah. In case no. When I get big now, I'll go have that. I'll be like investing in like NFTs and like Dogecoin and all kind of thing. You know?
Okay,
Yeah.
sir.
Alright. So Akil, you ready to start? Let me know.
Yeah, I already said.
I bet. So get us a read for me.
Okay. That's not I need to zoom in. Right. WXYV is a parallelogram in which VY is equal to A and VW is equal to B. S is a point on WY such that WS to S dot Y is equal to 1 to 2 ratio.
Alright, before we even do anything, we like to understand what's going on before we do anything.
Yeah.
So they're saying V to Y is A. V to Y is A. Do they already have that labeled?
Yeah.
Are you seeing my screen moving on now?
Yeah. Will I move in?
Wait, one moment. It's weird. You seen it now? You seen it now. You're moving, right? Right.
Yeah.
I bet. So V to Y is A. So V to Y is A. We're seeing that they already have that labeled, right? And V to W is B. V to W is B. Great. And they're telling us S is a point on WY. Well, we could see that. This is WY. And this is the point S. And they're saying WS to SY is 1 to 2. Now, I know everybody that looking at this might be real confused with these ratios thing. So, Akil, this is what I want you to do for me. I want you to look at WS and I want you to look at SY. How much WS's do you think it's gonna take to make SY?
3.
To make SY, yeah? SY, S to Y.
Oh, 2.
2. So, Alex, I'm not sure if you've seen that, right? But if you were to look at this, how much WS's you think it would take to make S to Y?
Repeat. WS's from to S to Y.
Now here I say it again, right? How much WS's? So this is W to S here.
Mm-hmm.
How much WS's do you think it'll take to make SY? I wonder.
2.
2, right? So if I wanted, and I could split up WY into 3 parts.
Yes, sir.
Right. And so WS would be a third, right? And SY would be what fraction of the entire thing? What do you think?
2/3.
Exactly. So I'm happy that we could understand that. And if you were to read it off directly from this, you'll see how it works. So if you add 1 and 2, you get what's 1 plus 2?
3.
1 plus 2 is 3. We have some scholars here, boy. 1 plus 2 is 3. Don't know? Right? Okay. And they're saying WS to SY is 1 to 2. So WS is 1. So this would be 1 to 1 1/3, and SY, right? 2 2/3. And just by looking at it graphically, diagrammatically, were we able to see that or not? Let me know
Yes,
if you was
sir.
able to see that.
Yeah, normally I
Yeah.
just watch it from on the diagram, sometimes I don't read the questions, which is a bad thing.
I do that too, but you gotta be careful. You gotta be careful, right? But let's see in that, like, you don't have to read this fancy mathematical jargon. You can look at it and see it for yourself. WS, right, is a half of SY. So if I wanted to make SY, I would need two WS's. And that is what it's saying over here, right? It's saying that you need two WS's to make SY. I know it's looking very complicated. It's looking very complicated. But when you look at it diagrammatically, it makes sense. So is everybody okay with why I said that WS would represent a third and SY would represent 2/3? Or nah? Talk to me.
Yes, sir. Good, sir.
Yes, I understand.
Alright. Great.
Excuse, sir.
Yeah,
You didn't
Nikolai.
put this up in the chat, sir.
Say that again.
You didn't put this up in the chat.
This is a real spontaneous thing, boy. It's a real spontaneous thing.
I now see you live, sir.
Yeah, real spontaneous thing. Right? Now, I have a question, guys. If we were considering the vector W to Y, I would say that WS is a third or what? WS is a third or what?
WY.
Yeah, we could see that, right?
Yep.
And I would say that SY is what fraction of YW? I mean WY.
2/3.
2/3. So if there's anybody confused at all, or I don't know the scene, let me know if all are confused. I will go over it. Alright, so I see Kylie here. I see Angeli here. I feel like I said your name wrong. But like, let me know if all are following. Making
Excuse,
sense.
sir.
Yes, sir.
What did I miss, sir?
Say that again.
How much I miss?
You didn't miss much. This is the first question. We just gonna do one question because I had to go and do work.
Oh,
After
okay.
this.
Thank you.
No problem. So let's handle the first question, right? So just by reading the question, we were able to figure out that if this entire thing is WY, if that entire thing is WY, then W to S would be a third of that, and S to Y would be 2/3 of that. So I hope nobody is confused. And you can see it for yourself. If this is WS, how much WS's would it take to make SY? It would take 2. So altogether, WY could be broken down into 3 parts. This is 1 out of the 3 parts. And this is 2 out of the 3 parts. So we're going to move on now. Word. In the first question, they want us to find for W to Y. W to Y. So Akil, if it's W to Y, where am I starting from and where would I want to go to?
Y and then to W.
Y and then to W?
Well, I mean W and then twice.
W then to Y, right? So we want to go from W to Y. What path could I take to go from W to Y? Talk to me.
WV and VY.
Are you all seeing that? So I'm gonna call upon somebody randomly here. Alex, well, Nicholas. If
Yes, sir.
if this is your mission, right? If you want to go from here to here, what path could you take? What path?
W to V and V to Y.
Exactly. That's not no rocket science and thing, right? Let me know if that makes sense.
It will be negative B and positive A.
Right. Now I want you to tell everybody why this is going to be negative B as opposed to positive B. Why
It
is
would
that?
be negative B because the direction we're going in the opposite direction of
Yes,
the B.
exactly. So guys, anytime you're going in the opposite direction, right? Anytime you're going in the opposite direction, the vector is going to change sign. It's going to change it because it changes direction, right? So if this is positive B, then and if you're going in the opposite direction, it's going to be negative B. The sign is going to change, right? So I see somebody saying, but the arrow is going forward. So look at the question, right? We want to go from W to Y. So we're starting from W and we are going to Y. That's what we want to do. Now we are looking at the diagram and we are trying to figure out, well, what routes could I take to go from W to Y? So I'm starting from W. So from W, I could go to V. And from V, I could go to Y. Now I want you to notice something. V to W is B, but it's in that direction. So if we are going in the opposite direction, the only thing that will change is the sign. So this turns to negative B. Over here now, you could see that V to Y is positive A. Are we going in that same direction? Yes, we are. So it remains as positive A. So my answer for W to Y is just negative B plus what?
A.
Right,
A.
negative B plus A. Now, guys, is that the only way I could have answered this question?
I could go from W to X, X to Y.
Excellent. That is what I was going to talk about. That's the alternative way you could have done it. You know, we like to look at alternative solutions because in maths, it don't just have one way you could do something. Multiple different ways you could do something and get the same answer. So, Kylie, talk to me. In this alternative approach, since this is a parallelogram, if this is E, what do you suppose this is?
Negative A.
Nah, that wouldn't be negative A. Watch. Look at this, right? So look at this, Kylie. V to Y in this direction is A. W to X in that direction will be what? What do you think?
Capital A.
No, come on, be the exact same vector. Just to clear up any point of confusion, imagine I were to draw this parallelogram here, right? If I told you that was 4 centimeters, what do you think this would be? Talk to me. What do you think that would be?
4 centimeters.
Great. If I told you that this was 9 centimeters, how much would you tell me here is?
9 centimeters.
I bet so. I will use the exact same thing over here. If to go from V to Y, you take a vector of A. And both of us could see that V to Y and W to X is the exact same distance, and we could see that.
Yeah.
And we could also see that you're going in the same direction.
Yeah.
So it's the exact same vector. So this is also going to be common A. You follow?
Yeah, so.
If this is V to W, and both of us could agree that these two sides will have the exact same length, let me know.
Yeah.
Right? And are they going in the same direction?
Yeah.
So we will call this.
Come on, B.
Exactly. Come on, B. We have it there. We have it there. So let's look at the alternative solution. So we wanted to go from W to Y, right? W to Y. So in the method that Akil and Nicholas used, they decided to take this route. But Kylie, we saw that that wasn't the only route you could take. If I want to go from W to Y, and I could also take W to X, and what next?
X to Y.
Yeah, X to Y, right? Now talk to me, right? If this vector in that direction is positive A, I want you to look at how we are moving. Are we moving in the same direction?
Yeah.
If we're moving in the same direction, it's going to remain positive. Okay. Now, I'm going to draw the arrow for this vector, right? This is VW here. And so YX would be over here. Talk to me, Lamon, if you understand now.
Yeah, so now it will be positive A minus or plus negative B.
Take your time.
I don't know. All I know is the B is negative and the A is positive. I don't know if the R will take away that.
I will share. Don't worry. So, does everybody understand that if you want to go from W to Y, you could go from W to X, and then you could go from X to Y. Now,
Yes, sir.
since you are going in the same direction, it's positive here. So it's positive A, right? And since you are going in the opposing direction, the opposite direction, instead of it being positive B, well, it's going to be negative B. So Kylie, to answer your question, this is what you would write for your solution. You would say W to Y is equal to A minus B. Or if you wanted, you could have written A plus minus B. But Kylie, you know that would work out too? What do you think our plus by minuses? Tell me, Kylie, a plus by minuses are?
Minus.
Yeah, so this would have just worked out to be A minus B. Now, Kylie, I get why you're confused. You're probably saying, well, sir, just looking a little different. Ain't you seeing that? You're probably saying,
Yeah.
these answers looking different, and
So it's because it basically reciprocated. It's like negative B plus A because in A is positive and B is negative. So you put the negative B in front and then you add the positive A.
right, so we are not changing anything, right? Reciprocate is the wrong word to use. We're not reciprocating anything. You just rearranging the order. So Kylie,
Yeah, okay.
that is okay. So can we see that this is positive A? Let me know if you're seeing that as positive A.
Yeah.
So if you wanted, you could have put the negative B first, and well, you could have put the A after. All of that is fine. All of that is fine. Right? Heck, if you wanted, you could have write this answer as A minus B. Understand?
Yeah.
Right. So is there anybody that does not understand how to go from W to Y? Let me know, guys.
Excuse, sir.
Yeah, Nikolai.
Can't you just go in a straight line from W to S and then S to Y?
Right. You have a good point, but Nikolai, do we know how you would go from W to S?
Well, I saw that was the 1 to the WY.
Uh-huh. Okay. But watch this, right? Then you would go from S to Y, and
Yes, sir.
okay. So according to what you're telling me there, you're gonna end up with a third WY plus 2/3 WY. What is that third plus 2/3?
Make it a whole 3 over 3.
Right, which is just 1. 1 by WY is WY. Does it make sense to say WY is equal to WY?
No.
Nah. So I hear what you're saying, right? If I knew what the vectors W to S was and S to Y was, I could figure it out. But the point is, we want to express WY in terms of A and B. If you say WY is equal to WY, you will not be answering that. We want to go from W to Y in terms of A and B. So like, how to move? How to use A and B, right? So Nikolai, let me know if you go with that.
Yes, sir.
All right, let's move on to the other question now. And my advice is, yeah, Kylie, talk to me.
So part B will be WS is equals to 1/3 of S.
1/3 of WY.
Oh, okay.
Dora, we'll understand why. So Kylie, look at this, right? Look at this carefully. Are you 100% okay with WY being minus B plus A? Talk to me.
Yeah.
Great. Now, when you look at the diagram, right? When you look at the diagram, how much WS's does it look like you'll need to make SY? Talk to me.
3.
It look, nah, not 3, 2. Watch. 2.
Oh, yeah.
But if we're talking about the entire thing, it looks as though you would probably need 3 WS's, right? But if we are talking about, if I'm comparing here to here, can you see that it's going to take 2 WS's to make SY? Let me know if you're seeing that.
Yeah, so
So, long story short, Kylie, I could split this entire thing up into, well, I'm seeing I could split it up into 3 different portions, right? So if that is the case, I want you to talk to me, right, and tell me, what fraction of WY do you think WS is? So look at it. This is WS. Talk to me, Kylie. How much of the entire thing do you think WS is?
1/3.
Right, so I would say WS is a third of what entire thing? It's a third of what entire thing?
WY.
Right. Great. And we would say that SY is what fraction of WY?
2/3.
Yeah, you would say 2/3, right? You'd say 2/3. right? W, Y. Is there any confusion in your head? Any at all? Any?
No.
No? All right, good. So here what we're going to do now, right? Here what we're going to do now. They want us to figure out W to S. Kylie, don't we know what WS is in terms of WY?
Yeah.
Yeah, WS is actually a third of what? WY. Do we know what WY is?
Yeah.
Yeah. Wait, how would you go from W to Y? How would you do that? How
We
would
could
you?
go from W to X, X to Y.
Right, and we came up with minus B plus A, right? That was the vector. Let me know if you're following.
Yeah.
So do you understand that WY is literally minus B plus A?
Yeah.
Right. So what I'm going to do now, instead of writing W to Y, I'm going to replace that with minus B plus A. Talk to me. Let me know if you understand that.
So instead of writing out the vector, you just write out the terms, right?
Exactly, because look at what they want. They want you to write in terms of A and B. So they want the answer in terms of A and B. So you need all the answers needs to be in terms of A and B. That's what they want.
As you said, right? If you didn't write the terms and you just write WY, would you still get a mark for it or not?
You get a mark. This is the start. But after you write this, you need to then substitute what you know for W to Y. And W to Y is minus B plus A. Is there any confusion?
No.
Alright, so I see somebody in the chat is kind of confused. Let me try to rectify this confusion, right? So a vector is essentially a set of directions. Like how would you go from one point to another point? Right? That's what it is. So we found earlier that to go from W to Y, it was minus B plus A. Right? To go from W to Y is minus B plus A. Do you understand that part? Do you understand that part? That if you want to go from W to Y, it's just minus B plus A. Let me know if you understand that part. Okay, I'm not hearing from any chat, but that is what's going on. If I want to go from W to Y, that is the scene. So W to S, I want you to understand that W to S is just simply a third of W to Y. That is what it is. So WS is just simply a third of W to Y. Great. Now, what exactly is W to Y? Well, we found earlier that if I want to go from W to Y, it is minus B plus A. So now, instead of you writing WY, you actually need to write what it is. W to Y is actually minus B plus A. Right? So Kylie, now we need to expand this. So Kylie, talk to me. If I were to expand this, everything inside the brackets, I need to multiply by what?
I think 3.
A third. A third.
Oh, yeah.
Right? Because you have a third here, so everything inside the brackets, you're going to multiply by a third. Everything inside the brackets is going to be multiplied by a third. So, let's look at this. What is a third by minus 1b? It looks more complicated than it seems. What is a negative by a positive, or vice versa? What's a positive by a negative? Talk to me, Kylie.
I think.
What is this?
And negative.
A negative, right? So we have a third by negative b. That's just going to be negative a third b. That's it. That's it. What do you think a third by positive a is going to give you?
1/3 A.
That's it? Easy or hard?
It's easy, but we look kind of teachy.
I understand in the exam, when we're not here in the Zoom meeting, it's going to look crazy. I get it, but it's the same procedure as you're following. Right? Okay.
But
S.
so why you're multiplying it?
We need to write our answers in the simplest form. So we need to expand it out. Our answers needs to be in its most simplified form. So this wouldn't be a complete form. So I expand it to simplify my answer. Yeah.
Oh.
Yeah, one third is positive. One third is a positive number. Right? Once you don't see a negative sign in front of it, it's a positive number. Okay. So S to X now. Who wants to help me with S to X? Nikolai, you want to help me with that?
Yes, sir, I don't mind.
I bet. So I want you to look at this diagram, right? How would you go from S to X? So before I do anything, I'm just going to connect S to X. So understand that we just want to go from S to X. That's literally it. S to X. S to X. How could we do that, Nikolai? How could it have multiple routes it could take? Which route are
Yes,
you
sir.
seeing?
Good. Well, I chose from S to Y and then Y to X. But
I
you
would
can also go from S to W and then W to X.
I would choose this as well. Why? Because it's in the same direction as WY. So it would not have changed no sign and thing. It's very
Yes, sir.
simple. Okay. Kylie, you there?
Yeah.
So Kylie, I want you to look at this closely, and if at any point you're feeling confused, just talk to me. I find I saying that plenty. That's my catchphrase. Talk to me. I had to change up that. I can't say the same thing over and over. Otherwise, I'll little clong, man. I know that. Because I just clong people that say the same thing over and over. So, like,
No,
you know,
I don't. People who do it, sir.
you think I would clong myself. Right? So, Nikolai, if I want to go from S to X, that's going to be S to Y plus Y to X. You agree?
Yes, sir.
Now, if you look at this, right? V to W is B. So what do you think Y to X is? And people on TikTok, or they could give it a shot too. What do you all think Y to X is? Y to X. Look
Would
at it.
also be B.
Yes. Y to X would also be B. Alright? I want you to observe the direction. Are we going in the same direction? Are we going in the same direction?
Yeah.
Right. So
Yes, sir.
Yes, sir.
So it remains as positive B. Okay, now the problem here is, do we know what S to Y is?
Yes.
Yes, sir.
Yeah, we actually know where it is, right? But we need to be able to write it in terms of A and B. So remind me, S to Y was actually what fraction of YW? Why I say that boy WY? Yeah, WY.
Two-thirds.
So that's WY.
And do we know what W to Y is?
Yes, sir.
What is W
Yeah.
to Y?
Minus B plus A.
Yeah, minus B plus A. So, in case you all confused, remember, initially we had looked at it and we saw that W to S would have been a third of W to Y. This entire thing is W to Y. And this small piece over here, well, I should say bigger, is 2/3 WY. So we agreed on that from the start. In the first question, they made us find what W to Y is. W to Y is minus B plus A. So anywhere that you see my WY, instead of writing WY, you need to write minus B plus A. Great. So over here now, I replaced WY with minus B plus A. Kylie, now we need to do what? Starts with E. Starts with E. E. Well, for me, exercise, because I sit down on this chair whole day. But for you, think of another word. It kind of sounds like exercise.
Expand.
Yeah, expand. Somebody say eat. Yeah, I hungry. I need to eat some food. Feeling for a gyro, boy. Lamb gyro. I go slap right now. I saw somebody had a hand up. Was it Tisha? Somebody had their hand up.
So that was a mistake.
You good though? You okay?
Yeah, I'm okay. I'm following.
All right. So Kylie, to expand this, you're gonna multiply 2/3 by everything that is on the inside. So you tell me what's right here. Let me see if you catch it.
So it will be 2/3 negative b.
Right. So be careful how you're saying that, right? So 2/3 by negative b. So positive 2/3 by negative b. So the
Which
entire
is
thing would be what?
2/3 b
Nah. You multiply now positive by a.
negative
So the final answer should be
positive
nah.
negative.
Guys, just a quick recap, right? A positive by a positive is a positive. A negative by a negative is a positive. Positive by a negative is a negative. A negative by a positive is a negative. So Kylie, long story short, 2/3 by minus b, positive 2/3 by minus, just minus 2/3 b. Right? And we're gonna write next. What are you gonna write next?
2/3 a.
Yeah, plus 2/3 a. Alright. Guys, talk to me. We chilling? We following so far?
Yes, sir.
Lovely. So now we could actually complete our answer for s to x. Remember, we said that to go from s to x, it is s to y plus y to x. So we just found what sy was in terms of a and b, seeing that, a and b, and we know why x is just simply b. So I'm going to write negative 2 over 3b plus 2/3 a, and then I'm going to write plus b. Guys, do you know what this corresponds to? That entire thing that I wrote, what does that correspond to? What is that? What is that?
Negative b plus a plus b.
Now asking which vector does that correspond to? Which vector does it correspond to?
SX.
Nana SX.
So would that be
SY.
SY?
Yeah, we just not come up with that, right? That's SY, right? So that's the SY part. And what does B represent? Which vector is
yx.
YX? Okay, so somebody asked me, how did you get the extra B? I didn't just pull out the B, right? Let's look at something. So again, my mission is to go from S to X, right? To do that, I need to go from S to Y and then from Y to X. S to Y is this part over here. And you're wondering, well, where did we get the extra B from? Watch, this is a parallelogram, right? So the parallel sides are equal in value and the same direction. So if this one is positive B, then this one is also positive B in the same direction. And recall, if I want to go from here to here, this is what I need to do. So notice it is going in the same direction, right? So, and it's in the same direction and is the same size. So I'm going to assign this to be B because that is how you would go from Y to X. So if you want to go from Y to X, you would have to take a vector B. So that's where I get the B from. The B just represents Y to X. Let me know if you understand that. So S to Y is this entire thing over here, right? And Y to X is just B. And I get that from over here because it's a parallelogram. Cool. Right. Now the next order of business. Can I leave it like this or do I need to simplify it?
You need to simplify.
Yeah, this can't do. Next thing. Are y'all seeing any like terms?
Yes, sir.
2/3.
Okay, how much of you all think that these are like terms?
No.
Some of y'all want to say yes. Let me explain why they're not like terms. Kylie, I want you to think of B as a bat. And I want you to think of A as a, what animal starts with A, boy? What animal starts with A?
Alligator.
Alligator. Talk to me, right? Could a bat and an alligator combine to make a child?
No.
No. No, that can't happen, right? So do you think the variable B and the variable A are like terms?
No.
No. Because if they like each other, they can't make a, like a bat and a, like, what they could do, right? A bat and an alligator. Think of it the same way like this, right? B and A are different variables, so they are not like in nature. Okay, so you catch that, right? Are you seeing any other bats in this expression? Look at it.
Yeah.
Yeah,
Because it is B.
we're seeing that. So this and this, they are an example of like terms. Great. So over here we have minus 2/3 B, and over here I'm adding B. Now, everybody, if I were to ask you guys how much B's it have over there, how much you would tell me? How much B's is this?
1.
1B.
1.
And if I were to ask you how much B's it have over here, how much would you tell me?
2.
Right, and I could write that as 2B, right?
Yes, sir.
Kylie, and I know that a lot of students have a hard time seeing this. They would look at something like this and they go scratch their head and they go be like, how much B's is that? It's a lot simpler than you think. How much B's you seeing? 1. So it's just 1B. So Kylie, you see that plus B by itself? That literally means plus 1B. You with me?
Yeah.
Right. Now, if you want to group together or simplify like terms, you're going to look at the coefficients. So we have negative 2/3 here and then plus 1. So what is negative 2/3 plus 1? Do you know? What is negative 2/3 plus 1? Do you know? If you're having a hard time with that, my advice is just plug it into your calculator. But I will show you how to calculate it. So I'm going to presume, sadly, that most of you will have a sharp. I'm going to assume that. Is that true? Do most of you guys have a sharp?
Hard.
Hard. I like that. You see how you use any word hard? That's a proper use of the word hard. I'll be a great English teacher. That's a good use for the word hard.
So the Casio calculator is the best calculator you can find right now.
That is what I saying. That is what I stating. Yeah, it just I know better than that. Right? I buy this knockoff Casio calculator the other day. Is the exact same thing as the Casio, just $105, cheaper than a Sharp. Why are we buying Sharps in 2026?
Sharp is bonus. Like nobody has
Sharp
used that.
is,
I have 2 though, but like
I don't know why I have two. That's called the hammer what? That's an
I have a
inside joke.
Casio and a Sharp.
Hold on.
Man is Lil Tecca over here, yes? I don't know if you get the reference. You know, like Lil Tecca made a song about I got black, I got white, what you want. You know the reference I'm talking
It's
about?
ironic because the Casio white and the Sharp black.
Man is Lil Tecca, yes? Man is Lil Tecca. Wow. I should have record this, boy. We that's how your real vibes to record. I don't know why I didn't record it.
Wait, so that's not recorded?
No, unfortunately it isn't. I didn't think to record it. Yeah. We'll continue, right? So if you are unfortunate and you have a sharp, this is what you're gonna do. So minus 2. I believe in the sharp calculator you should have like a R button. But hey, here what? Just press divide.
So it is via A and a fraction BC.
I will press that and put that in brackets, right? Then you're gonna press plus 1, and you should get 1/3. If you're not seeing 1/3, you go see 0.3333333, which is that too.
So wouldn't it be easier to just use the fraction button?
If you have a Casio, yeah. If you have a
Oh.
Casio, sure.
Yeah.
If you have a
Okay.
Sharp, this is what you gotta do. Right? If you have a Casio, guys, this is how easy it is. If you have a Casio Bro, that's it. That's it. No brackets or anything. Very simple. The way life should be. Okay. Now, let me show you guys the long way, right? So, Kylie, you there?
Yeah.
So, if you want to add or subtract fractions, the denominator needs to be the what?
Okay.
It needs to be the same. So, is there any way I could write 1 as some number over 3? What over 3 is 1?
3.
Right, so I could write 1 as 3 over 3, yeah? That makes sense.
Yeah.
And so now I have minus 2 plus 3. Where's minus 2 plus 3? Yes, son, where is goated? Yeah, where's minus 2 plus 3?
Positive 1.
Positive 1. So you end up with 1 over 3. So for b, at least it's going to be 1 over 3b. And do I have any other a terms? Or that's the only a term?
That's your need.
Right, so I'm going to write plus 2 over 3a. We okay with that?
Yeah.
Then that's it, you know. That is literally it. Right, so minus 2 over 3 plus 1 is equal to a third. And if you don't understand why, look at this again, right? So if you want to add or subtract fractions, the denominator needs to be the same. So 1 is the exact same thing as 3 over 3. I go in UE. I'm doing my bachelor's in electrical and computer engineering. This live finishing just now. Right? This live finishing just now, unfortunately. But it was nice. I just do a random live and like 38 people on TikTok join and thing, and wow, I wasn't expecting so much people. Random people. It's nice seeing you all. But yeah, minus 2 over 3 plus 3 over 3. Minus 2 plus 3 is 1. 1 over 3. So did everybody understand how we got SX is a third B plus 2 thirds A? Let me know, guys. Let me know.
Yes, sir.
So,
Right. Alex, Kylie, I've seen some other people here. I've seen Kelsey. I don't know who Kelsey is, but big up yourself,
Yes,
Kelsey.
sir. All good.
Big up yourself, Gary. Big up yourself, Alexia. Right? Respect. So, like, that's the answer for SX. Nice. If I have time, I could always look to try and do at least one question on a Tuesday. On a Monday. I could at least do something like that. That would be manageable for me. I could
What
do
time?
that. Probably like 6, 7. Like 7 to 8 or something. 7 to 8 or something.
Say
but
again.
that's gonna be nice to in bio class.
You still in bio class?
And yeah, it starts 6 o'clock and about half 8 it is finished the latest.
Raise boy. But I don't know what to say. The thing is, I'm so busy. Whenever I get a chance, I get a chance. So I would like to cater for people, but it's extremely hard to cater for people. The best I could do is help when I get a chance, right? So it mightn't align with some of you guys' schedule, but I will help when I get a chance, right?
Okay.
Is everybody all right with questions A to C?
Yes, sir.
Right? Good. Nice. Tisha, Kelsey, Akil, Kylie, Alexi, Gary Griffith. Gary Griffith in class. Big up yourself, Gary Griffith. Right? Gary staying quiet.
Yeah, okay.
Alright, bless.
Me too, sir.
Bless. So let's move on to part 2 now. Okay, I want somebody to read this. Who wants to read this for me? I don't like to read. Don't like English.
Sir, I don't mind, sir.
Alright, Nikolai. Give it a read for me.
R is the midpoint of VW. Prove that R, S, and X are collinear.
Okay, when I show that it's collinear, bet.
Right, sir, man. I don't know if you're spoiling, man, but no.
Wait, sir. Give me a second. second. Trying to get this. Akil, I'm just seeing it. I'm just seeing it on the screen.
Yeah.
Yeah, this is you. That's you. You know Eminem, right?
Yeah.
Okay, okay. Anyways, I will continue. The first order of business is, does anybody know what collinear means? Collinear. Do we know what collinear means?
When
Yes, sir.
points on the same line. So if I have points on a line and I have to be able, so like, and if you draw a line with regular, the points supposed to line up on a straight
Exactly.
line.
Exactly, right? So collinear means that the vectors, number one, the vectors are in the same direction and they have a point in common, because that would mean that they're both starting from a common point. Or let me show you some examples of what I'm talking about, right? That's the best way to see it. Let's just say I had a vector here, right? And you all see that the vector is pointing in a specific direction. And all you see in its size, right? I'm gonna follow you seeing
Yes,
that.
sir.
Okay. Now I'm going to draw a second vector. What do you notice about the second vector?
It's 2 times bigger.
It's 2 times bigger, and in addition to that, it's also going in the same direction, and isn't it on the same
Parallel.
line?
Yeah.
Yes, sir.
Yeah, so these two vectors would be collinear. Now, a big thing about collinear vectors is you need to be able to show that they are scalar multiples of each other. And why is that? Let me try to understand why is that. So Kylie, when you look at these two vectors here, right? You notice that the blue vector is how much times bigger than the green vector?
2 times.
So think about it. If I could write one vector as a multiple of the other one, and that would mean they're going in the same direction, one just a bit longer than the other one.
Yeah.
Yeah, so that is why if it's a scalar multiple, it proves that it's collinear, but that's only part of it. Talk to me. And this other vector over here, and this other vector is also going in the same direction as this one over here.
Yeah.
But would you say it's collinear to the green vector? Is it on the same? Is it on top of the green vector?
No.
No. So to make sure it's collinear, both of them needs to be starting from a common point, or they must have a point in common. So in this instance, and we can see that both the green vector and the blue vector starting from a common point. And you can see that.
Yeah.
That means that's Siemens that they are collinear. Right over here now, they're starting at a different point, and you can see that this could be point A, this could be point B. Great. So just to cut all of that short, anytime you see the word collinear, you're looking to see if you could write them as scalar multiples of each other. And you're looking to see if it have a point in common. So Nikolai, let we do this question, right?
Yes, sir.
Okay. So Nikolai, they're saying that R is the midpoint of VW. If it is the midpoint, wouldn't it be in the middle?
Yes, sir.
Right, it will be in the middle, right? So R is going to be in the middle of VW. Do you agree that it would be right there?
Yes, sir.
Good. And they want us to prove that R, S, and X are collinear. Now, if you connect R, S, and X, does it look like they're on the same line?
Yes, sir.
Could everybody see that? Does it look like they're on the same line? R, this is R. Does it look like R, S, and X on the same line? Let me know.
Yeah.
Yeah, but we need to be able to prove that, right? That's what we need to be able to do. We need to prove that. Awesome. So let me show you how we could prove that.
Oh, this thing really easy, man.
It is. It's only looking hard, right? So Nikolai, here a way to do for me. If it's collinear, you need to prove that they're scalar multiples of each other. So you could do this. Maybe you could compare this to this, or you could compare this to this. Either one is fine.
Yeah,
Now
I
you-
think it just go in any direction, like from R to W and then W to X.
You want to go from R to W and W to X?
Yes, sir.
Sure, that's not a problem. And that would be R to X, right? Yeah, that would be R to X. That would be the entire vector. Now, this is where I lose students, so I want to make sure you all are following. This is what Nikolai suggested. Nikolai suggested that, if you want to find the big vector, the entire thing, which is R to W, he said that we could go from R to W and then W to X. Does everybody agree with Nikolai? If I want to find the entire vector, do you all agree with Nikolai?
Yeah.
Okay. Now the next thing I would have to ask, if this entire thing is B, what does it make here to here if B is the midpoint?
Half
It'll
of
be
B.
half B.
1/2 of VW.
Half, that would be half of B. Now somebody said half of BW. Let's recalibrate for a moment. So we know that from V to W, that entire thing is B. The entire thing is B, right? So if it cuts it in half, this will be a half B. B is the actual vector, right? So half of that would just be a half B. You understand?
Yeah.
Right? And this would just be what? What would this be? What would that be?
A.
That would be A, right? That would be A. Great. So long story short, if I feel like I say real plenty, boy. Long story short, I'm gonna try to expand my vocabulary. Give me a second. In other words, R X is equal to R to W plus W to X. What did we say R to W was? What was R to W?
R to W was a half B.
And what was W to X?
W to X was A.
Great. That's the answer for R to X, right? Now, if I want to show that these points are collinear, then I would need to prove that the vectors along this line could be written as scalar multiples of each other. So Kylie, when you look at this, right, and we can see that this entire thing is the big vector, the whole vector R to X. You see that, right?
Yes, sir.
How much RS's do you think it would take to make the entire thing?
3.
It would take 3. So maybe, here what I was saying, right? And it looking like maybe I might be able to say that Rx is equal to 3 RS's, and that might be possible.
Yeah.
Alternatively, I could say that RS is what fraction of Rx? Talk to me.
So would it be a third?
It would be a third. So if you could prove either one of these, you're Gucci. You're set. Right? So we could do that, right? We could do that. But you see, in the last question, we found for SX already. We found for SX. So, hear what I'm saying. Rather than us doing extra work, we could use SX. So, Kylie, let me explain what I'm talking about. So, Kylie, if this is the entire vector, right? That's the entire vector. What fraction of the entire thing do you think SX is?
2/3.
2/3. So, and I could also prove it if I could say that SX is equals to 2/3 Rx. Wouldn't I also be proven that is a scalar multiple?
Yeah.
Now, that whole talk about scalar multiple is sounding scary, but scalar multiple just means you're multiplying one by some number to make it the same as something else. So in this case,
Yeah. And then like if you have 2 and 4, it would be the scalar multiple of it would be 4 and 8.
no. A scalar multiple is just a number you're multiplying by something. So like a scalar multiple of 20 is 40 because I multiply by 2. I scaled up 20. So a scalar multiple is literally just a multiple you're using to make something bigger or smaller. Right? So in the previous method, I would have had to go and find RS. Do you think you understand why I'm picking SX or not?
Yeah.
Because SX, we found already. We have that. We don't have to go and look for that again. We have it. And when you looked at it, we saw that SX kind of looks like 2/3 of RX. And you saw that?
Yes, sir.
So that's what we're trying to prove, right? That is what we are trying to prove. So let's actually prove that. So SX, this is what SX was, right? So SX was equal to a third B plus 2 over 3A. So stay with me, right? If at any point you're feeling lost, just talk to me and I'll try to make sure you don't get lost.
Okay.
So do you understand that this is a visual observation? We observe that. We observe that. That doesn't necessarily mean it's true, right? But we're trying to prove it. Okay. So we know that SX is a third B plus 2 over 3A. That's what we know. And we know that's what SX is? Talk to me. Let me know.
Yes.
What is Rx? Remind me, what is Rx? What was our vector, Rx?
A half B plus A.
A half B plus A. Now, if my theory was correct, when I expand this out, what am I supposed to get if we are correct? If we are correct, when I expand this out, it is supposed to be equal to what vector?
SX.
Yes, you are correct. I feel like some people confused. If it is collinear, it means that you could write any of the vectors on the line as a scalar multiple of the other one. So the first thing we did was we found for the big vector over here. The observation we noted, we saw that SX kind of looked like if it was 2/3 of the entire thing. So if it is collinear, then we could prove that relationship. So we said that SX was 2/3 of RX. This is what RX is, and this is what SX is. So Kylie, do you understand that this step over here is just proving what I wrote over here?
Yes, sir.
So Kylie, do you understand that this is SX?
Yeah.
And it's 2/3 RX, right? Do you understand that this is RX?
Yes, sir.
And if it is correct, when I multiply this out, what am I supposed to get? What am I supposed to have proven? So that's supposed to be equal to what? What is it supposed to be equal to?
RX.
Nah, this is 2RX. What is 2/3 RX supposed to be equal to?
SX.
SX. Kylie, look at it again, right? What is 2/3 RX supposed to be equal to? Supposed to be equal to mathematically.
Yeah, I understand.
It's supposed to be equal to SX. Right? So let's see if that's true. So Akil, let's multiply this out, right? So Akil, what is 2? Well, if you observe, right, the 2 and the 2 gonna cancel off here, so you're gonna be left with what?
1/3.
Right, 1 over 3b. And what is 2/3 by a?
2/3 A.
So did we prove it?
Yeah.
Right?
But since if you could use two different points, like what I did.
Wait, so I'll check what you did just now. So therefore, Sx is equal to 2/3 Rx. Right? And guys, if that is the case, is there a common point? Like if you're looking at if you're comparing Rx and Sx, is there a common point? Look at that. If you have Rx and Sx, is there a point in common that both of them share?
Mm-hmm.
What point?
S. Yeah, S.
F.
I see in that X. And you see what I'm talking about? Both of them starting from that point. Both of them
Yeah.
going to that point, right? Both of them going to that point as the point that they have in common. Right? So they are scalar multiples of each other. And have a point X in common. Alright, so that proves that they are collinear. That proves that they are collinear. Wait, I don't know why TikTok always thinking I'm a robot. I have to slide a puzzle to make a dog. Okay, TikTok. Okay, I'm not a robot. Great. I'm happy to hear I'm not a robot. So let's just summarize what we did here. So a vector is collinear. So okay, 2 or 3 or how would I show that vectors are collinear? Or how would I show that points are collinear? Does anybody know? Based on what you saw just now, how would I show if things are collinear?
The multiple of each other.
Right, you could write one vector as another vector by using a scalar multiple. So I could say that, say vector A is a scalar multiple of vector B. So in other words, you could use one vector, right? I could let me give you an example. So this is a very simple example. Look at this example. We call the blue one vector A, and I call the green one vector B. And I would be able to say that vector A is just 2 times vector B.
Yes, sir.
If you could do that, that means that they are scalar multiples of each other. So I can represent vector A using vector B. That's like the first thing you have to prove. The other thing, you have to look out for a point in common. Right? So a point in common. So they wanted us to prove that Rs and X were collinear. So I connected Rs and X. They do look like they're on the same line. If I want to show that they are collinear, then this is what we're doing. We first found for Rx. So Rx is that entire vector over there. Right? And we found out that was a half B plus E. Now in the prior question, we found Sx. Now, just by looking at the relationship, we could see that we could cut this up into 3 pieces. And if we could do that, maybe you might be able to see that Sx looks like 2/3 of Rx. So if you could actually prove this mathematically, then they would be scalar multiples of each other. So if you could prove this, they are definitely scalar multiples of each other. And well, did we prove it? Yes, we did.
Yep.
We did, right? Because this is R. If you want to go from R to X, it's just a half B plus E. So this is R to X. And from the prior question, if you want to go from S to X, that is the vector you take. This is what we kind of noticed. So I wrote it down and then I proved it. So therefore, Sx is equal to 2/3 Rx. So then I would write they are scalar multiples of each other and they have a point X in common. If that part is confusing you, look at it again. So this is R to X and this is S to X. What point do both of them have in common?
The point X.
Yeah, the point X, right? Because both of them go into point X. So I hope everybody is okay with that specific example. Right? Let's see how you did it. Okay, so Akil did it.
Yeah.
I'm not sure if you was paying attention, but when I was now looking at the question, I said that I was doing it with R to S, but then I shifted gears to S to X because we already have it. That's why I did
Yeah.
that. But if you do it R to S, you'll be fine. You should be 100% fine. So let's test it with RS instead, just to alleviate any concerns you might have. So just to go back from the start, Akil, they said that R was the midpoint of what vector? R was the midpoint of what vector?
Was it WB?
Right. So that would make this a half B, and it would make this what?
Mhm. Oh, happy.
A half B. Now we are trying to show that points R, S, and X are collinear. So we're going
Mhm.
back to the initial way I was going to do it at the start, but this time I'm not going to be lazy. We're actually going to find the extra vector RS. Just by looking at this, and you could kind of see that it would take 3 RS's to make up the entire vector Rx. And you can see that?
Yep.
We could see
Yeah.
that. Isn't that what you did?
Yep.
Great. So again, guys, if I want to go from R to X, wouldn't I have to go from R to W and then from W to X? Are we 100% okay with that?
Mhm.
So this
Yes,
is
sir.
a half B again, there's a half B, and this is A. Why is it A? It's A because we're dealing with a parallelogram. Parallel sides are equivalent. Lovely. So R to X is just simply a half B plus A. Now, Akil, you would have noted that R, you notice that R to X, it looks like to make Rx, you would need 3 RS's. So maybe you could write that down somewhere and try to prove it. Good.
Okay.
So now, to figure out this puzzle, you need to find for R to S. You'd need to figure out R to S. So if I want to find R to S, how would I go from R to S?
RW plus WS.
R to W, yeah, R to W.
And WS.
Okay, let me know if any of you all are confused by that. If I wanted to go from R to S, is anybody confused by that? Kylie, let me know if you're confused by that. If I wanted to go from R to S, does this confuse you?
No, sir.
All right, what about the rest of you guys here? If I wanted to go from R to S, can you guys see that this is a route I could take?
Yes, sir.
Good, good. Right, I'm happy that you all are able to see that. Yeah, it is the triangle law of vectors, but when I'm teaching it, I just try to teach it in a way that you don't have to remember anything. Like when you look at the diagram, you can figure it out. Because it come like it is literally like you're walking. If I want to go from here to here, I will walk from R to W, and then I will walk from W to S. Great. So let's see if we could find RS now, quickly. So R to S is just simply R to W and W to S. We know that R to W is what? What is R to W?
Half B.
Right? A half B. And W to S. What is W to S?
1/3 of WY.
Right? And we found that to be minus a third B plus a third A. Right? I just
Mhm.
was it that?
Yep.
Okay, good. So we found for W to S earlier today, right? We found for WS earlier today. So let's continue. So this is just going to simplify to a half b, right? And we multiplying everything inside here by a positive. That is not going to change anything because a positive by a negative is a negative, and well, positive by a positive is a positive. So I'm just going to write back what is on the inside. Are you guys seeing any like terms over here? Let me know.
Yes, sir.
B.
Yes, sir.
What like terms are you seeing? A or B?
B.
B.
So
So
we
I have
have,
minus. That's it.
right? What is a half minus a third? To work that out, we could multiply top and bottom by 3 here, and the top and bottom by 2 here. You're going to end up with 3 over 6
Aye.
minus 2 over 6.
That'll
Which
be
is-
1/6.
Yep, 1 over 6. So it's going to work out to be 1 over 6b, right? Plus a third e. Chat, let me know if we extremely unequivocally confused by this. If we're extremely confused by this, just talk to me and I'll try to clear it up. Are we confused? Confused. If you are, tell me. That's okay. Confusion happens. Just talk to me. Anybody in the Zoom meeting confused?
No, sir.
No, sir.
Alright. Feel like someone is shy and all they don't want to see. Let me run it back quickly. So how would I go from R to S? Well, I could go from R to W, right? Which is just a half B. And then, how could I move next? What's my next move?
W to S.
W to S. Great. Right? So, long story short, if I want to go from R to S, I need to go from R to W and then W to S. Nice. Which is what I wrote over here. Now, R to W, that's literally a half B. It's a half B. Nice. W to S. W to S, we found that earlier, right? When you looked at the original diagram, we saw that W to S was actually a third of the entire thing. And we figured that out from the ratio, right? Right. And well, we know that W to Y is minus B plus A. So all things considered, we were able to figure out earlier that WS is just simply minus a third B plus a third A. Good. So I hope you guys following. So if I want to go from R to S is a half B, right? And over here, from W to S is minus a third B plus a third A. So all I did was I just combined that over here and I simplified and I got 1 over 6b plus 1 over 3a. Are you all hearing me properly by chance?
Yes, sir.
Okay, good. So Akil, this is the part where we try to prove this. This is the part where we try to prove this.
Yep.
So we know that r to x, right, is actually a half b plus e, right? So I could write a half b plus e. And I am trying to prove that that is equal to 3rs. So, this is what I'm going to do. I'm actually going to write 1 over 6b plus 1 over 3e. Tell me, are there any common factors over here?
B3.
Yeah.
3. If I were to say pull out the 3, right? That would be what?
A half B plus 1E. No.
Nah. Take your time.
Will it be a half B?
Hobby?
Wait, So Nikolai, let's look at this carefully, right? So what would I need to put here to multiply to give me 1 over 6? Do you know?
No, sir.
Nah. Okay, Akil, you have any suggestions?
For what?
So if I factor out 3 from this, if I factor out 3 from 1 over 6, what would that be?
A fraction of 3 from 1 over 6.
Mm-hmm.
Um,
Sir, wouldn't that be 3 over 6, which should be 1/10?
half?
No,
Is that half?
it'd actually be 1 over 18.
Oh, yeah, 1 over. Yeah, okay. Because if I divide 1 over
Yeah.
6 by 3, yeah.
But the easiest approach, let me just show you the easiest approach, right? We said earlier that R to X is 3 times RS. Can we prove that? Let's see if we could prove that. What is RS?
160 plus 130.
If I were to expand the brackets, would I get back a half B plus A? What is 3 by 1 over 6? Tell me, guys. What is 3 times 1 over 6? What is 3 times 1 over 6?
That will come to the
Uh-huh.
we have
Right, that would be 3 over 6B. And Kylie, if I multiply, say, 3 by a third A, what is 3 by a third A? So Kylie, what is 3 by a third? What is 3 by a third?
That's answer.
So if we have 3 multiplied by a third, it's actually simply going to be 3 by 1, just 3. So 3 over 3. So that'll be 3 over 3A, right? 3 over 6 simplifies to what?
1.
A half. Because 3 is a half of 6. So a half B, and 3 over 3 simplifies to just 1. Were we able to prove that Rx is actually 3 times Rs? Were we able to successfully prove it?
yes, sir.
Akil, were we able to successfully prove it?
Yes.
Right, let me see what you did. Right. Right. Okay. And right. So from here to here, you gotta be careful with how you're writing your work, innit? You gotta tell me, what does this represent?
That was the RS, I believe.
So you need to write that as equal to RS, and this is equal to what? What is this?
Look, you see, right? The, we can just, let me see. SX, I believe, yeah.
Alright. So what is that?
I think
SX?
that's SX.
SX.
Yeah.
Is that what SX is? A third B, yes, that is
Yes, sir.
SX. Right? This is SX. Right? And this is RS. Now, if you want to do the full working, this is what I would tell you to do. So, if I'm looking at RS, so we know that RS is equal to 1 over 6B plus 1 over 3A.
Mm-hmm.
If I were to factor out 2 from... Okay, if I were to factor out, say... Yeah, if I were to pull out 2 from that, what I write inside?
1 over 12.
1 over 12. Wait,
B.
that is not what we want.
Oh, you have to get the highest one.
Wait, give me a second. Right. Okay. Okay, if I pull out a half, right? If I pull out a half, what by a half would give them back 1 over 6? Talk to me. What by a half would give me back 1/6?
The third.
A third, right? So on the inside, I could actually write a third b, yeah. And this is the tricky bit. What would I multiply by a half to get back a third? What would I need to multiply by?
The 1/6.
Nah.
Too much.
I would need to put 2/3.
Yeah.
And let me explain why we're doing this, right? Akil, if I could do this, and you could show that RS is actually a half of SX,
Yeah.
yeah, that is the working you need to include if you're gonna take this route. You need to include that route. You need to include the working with where you pull it out, and you do the substitution to show that it's a scalar multiple. Yeah, they want to see
Okay.
that line.
I think I just leave all that part. Yeah. Okay.
Okay, if I look confused, right? Look at this. Look at this carefully. There's another way you could do it. If you don't want to prove it, there's another way you could do it. So this is what RS was. RS was 1/6b plus a 30. So Kylie, I'm gonna call upon you, and I want you to try your best to understand what's going on. Try your best. So Kylie, check this out over here. That's what R to S is. And this is S to X. Alright, so Kylie, you there? Can I hear from Kylie? Alexia, let me know if you're there.
Hi.
Right, so Alexia, if we are looking, if we are comparing R to S and S to X, it looks as though that RS is what fraction of SX?
A third.
Nah, look at it again, right? So this is
Mm.
RS over here, right? And this is
Mhm.
SX. How much
Yeah.
RSs do you think it would take to make SX?
In total, 2/3 or 3/3?
Nah, it would take 2. I'm not talking
Okay, so
about
two.
R to X, you know. I'm not talking about R to X. Look at it again.
Okay.
Check it out. So this is R to S, right? This is R to S.
Mhm.
And this is S to X. This is S to X. It would
Okay.
take two. It would take 2 RSs to make SX. See that? On
Yeah.
let me do it one more time. So this is RS, right?
Mhm.
Let me know if you've seen it now.
Yeah.
So what Akil tried to prove, right? This is what he tried to prove. He tried to prove that RS will be what fraction of SX? What does it look like? RS is what fraction of SX?
2 times
Nah.
2.
RS is a half of SX because it would take 2 RSs to make SX.
Oh.
Check it out again, right? So if this is RS, right?
Mhm.
Wouldn't that just be half the length of SX? Okay, I feel like we're real confused. Let me take things. Let me like step back a bit. This is RS over here. That's RS, right? This is RS, and this entire thing, the entire thing is SX, right? Which one is bigger, RS or SX?
SX.
SX. How much times bigger do you think SX is compared to RS?
2 times.
2 times. So I think the easiest one for you to see, you would probably say that SX is 2 times what?
RX.
Not RX. Be careful.
No.
That's not R to X. That's R to
S.
right. I think that would be the easier one for you to notice. The half one might be a little confusing, but you're seeing what I'm talking about, right? RS is actually a half of SX. Oh yeah, you seeing it or not?
Nah.
Nah? Okay. Well, we're gonna stick with this one. I think you're seeing this one for sure. because it taken 2 RS's to make 1 SX. You okay with this one?
Yeah.
Okay. Right. So to cater to you, I'm going to do it the way that you saw it, right? So you saw it with your own eyes. You saw that SX is actually how much times RS? Remind me.
Twice.
Twice. So that's what you saw with your own eyes. If it's actually true, wouldn't I be able to prove that mathematically?
Mm-hmm.
Okay. So I'm trying to prove that SX is the same thing as 2 times RS. So what is SX? What is SX? Talk to me. What is SX? What was that vector? Check it out over here. What is SX?
A third B plus 2 thirds A.
Right, so green guy, you see vectors, it has so much different ways they can answer the same question. And I think when students see it has so much different ways to answer the same question, maybe they might tell the classmate, you do it wrong. Or like has some really, really interesting teachers that would be just because they didn't do their way, they would be like it wrong. But truth be told, there's so much different ways to work out one question in vectors. And I feel like that's what causes the confusion. Because as you would see, I did it one way, right? Akil did it another way, right? And I'm showing another method as well. All of that would be correct. All of that would be correct. Right? So Alexia, you was talking?
No, I don't think so. So
Who
after that, it's B plus 2 thirds A.
wait, who I was talking to?
Me. Yeah.
Alright, well let me continue, right? So you saw this with your own eyes. We saw that with our own eyes, like our own eyes. Well, if I take off my glasses, I can't see nothing. So I don't really have to put on my glasses. My 4 eyes. I saw it with my 4 eyes. Use my glasses. Use my glasses by chance or not?
Oh, not yet.
Not yet? Okay. Well, soon to be 4 eyes. Over here, and you can see that this is SX.
Yeah.
Right, so I'm going to write that over here. So SX is a third B. You know what? I'll show you it a different way. So we are trying to see if I could write SX as 2 RS's. Let's see. So SX is, we know that SX is a third B plus 2 thirds A. I have a question. If I were to pull out 2 from that, what would I write in the brackets? So what would I have to multiply by 2 to get back a third? This is the part where it kind of confusing, ends.
Yeah.
Okay, if I am multiplying by 2, I would have to divide by 2. What is that third divided by 2? Okay, that might be a little complicated. Okay, think of it like this. What's that third by a half? What's that third by a half? A third by a half. Okay, so a third by a half. 1 by 1 is 1. 3 by 2 is? 6. So if I multiply 2 by 1 over 6, I'm going to get back a third. If you don't believe me, watch. 2 into 2 is 1. 2 into 6 is 3. So I get back a third. Right? So if I pull out 2 from this, it's going to be 1 over 6b. And if I pull out 2 from 2 thirds, what would I write?
A third.
A third A, right? Now I want to point out something very, very important. Talk to me, right? What vector is this? What is that? What vector is that? I think I see that before, I think I see that somewhere. What vector is that?
RS.
That is RS. So were we able to show mathematically that SX is actually just 2 times RS?
Yeah.
Yeah. Now that's one way you could do it, right? Or you could do it the easier way, which is like the proof method. I think that easier. Right? Watch that. Let me show you what I'm talking about, right? I see it has so much different ways you could do the same thing, and this is what has caused students to get confused. But if you understand the maths deep enough, you'll understand everything, and everything will make sense. So, Alexia, Sx isn't Sx a third b plus 2/3 a?
Yeah.
And according to this, what I'm seeing here, if I multiply rs by 2, what am I supposed to get?
If I multiply Sx.
I'm supposed to get Sx, right? So rs, remind me, what was vector rs? What was the vector for rs?
6b plus a 30.
It was 1 over 6b plus a third a, yeah?
Mm-hmm.
Now let's look at this with our eyes, right? What is 2 multiplied by 1 over 6? What is 2 multiplied by 1 over 6? So 2 multiplied by 1 over 6. Tell me.
So I have a question.
Yeah, Akil?
Is there a way to figure out the scalar faster?
Yeah, there's an easy way.
A third.
I'll show you just now, right, Akil?
Yes, sir.
Alexia, a third, right? So that's going to be a third b, right? And if I multiply 2 by a third, what that will be?
2/3.
Were we able to prove that the left-hand side was equal to the right-hand side?
Yeah.
Yeah. So that means they're scalar multiples of each other, and you just proved it.
Okay.
This is easier approach, I think. Right? Now, Akili was asking me if it have an easier way to figure out the scalar multiple.
Yeah. Because sometimes I just like randomly watch them like, okay. But I want to like know for sure.
Like, you're asking me how come I know it's 2rs?
Yeah. Like I want an easier way to figure out this scalar.
The easiest way, I mean, like, I could tell you is look at it and see. Like, when you look at this diagram, and you can see it for yourself, that it would take 2 RS's to make SX, which is what you did. Didn't you eventually prove
Yeah.
that it took, watch, check it out for yourself. How much RS is it taking to make SX?
2.
Right? So this is my advice for you. Look at the diagram and try to infer something. Try to at least infer something. And then work your way
Okay,
towards
okay.
it and prove it.
That makes sense.
But another hack I could possibly give you, right? If you're taking this route of the pulling something out, let me show you what you could do. This I go to hack as well. Again, I really hope I'm not confusing all here, but like it genuinely have so much different ways it could work the same thing out. It's crazy. So like if you understood a specific way, just like forget about everything else. Whichever way you understood, just stick with that. Quickly, Akil, could you just tell me what SX was? Quickly, what was SX?
I'll be this one.
Come on, fast. Speed.
I don't know speed right now. I am all over. SX. What was I saying? Oh, that was not a third B plus 2 over 3.
It was a third,
A third b plus 2 over
2 over
3.
3
and what was the other one?
RS. That's 1 over 6B plus 1 over 3.
Now let me show you this goated hack. Well, ain't you already seeing that they're on the same line? Ain't you already seeing that they're on like all the points on the same line?
Yeah.
So
So,
logically, you know for a fact that they are supposed to be scalar multiples of each other.
Yeah.
So this is what I would tell you to do. I want you to write SX over here for me. SX. And I want you to, and if it's a scalar multiple, I could write it as some number by RS.
Mm-hmm.
Yeah, we're on the same page on that.
Yeah.
And if it's a scalar multiple, and that means you could write one of them in terms of the other one,
Yeah.
you're sounding a little confused. And if you are confused, talk to me. I don't bite. Just be honest with me.
Yeah, again, true.
Again, check it out. Check out the diagram. When you look at the diagram, how much RSs it would take to make SX?
SX, it will be 2 RSs will make up SX.
Right. So you see how we could write one of them in terms of the other one? Scalar multiple. That's what I mean. So I trust I understand it for sure.
So you see that RS and SX are scalars of each other.
Right. So this is what we're gonna do. So we know that it's some. We know for a fact that we could write SX as some number times RS. So look carefully at what I'm going to do. So I'm going to write RS, and I want you to observe what SX is. SX is a third B plus 2/3 A, right? Seeing that?
Yeah.
Okay. So I want you to ask yourself, okay, what could I do with 1/6 to get a third? An even simpler question for you is, what could I do with a third to get 2/3? Or would I have to multiply a third
Multiply
by
by 2.
exactly? So just like that, I get your answer. Bam. That was real easy. That was so easy. And then you could just write on top. That's it. So how does hack this work, right? Once you recognize that all of the points on the same line, once you recognize that, you know for a fact that I could write one of them as a scalar multiple of the other one. So in this case, I wrote SX. And again, since they're on the same line, we know that this is supposed to work out. Right, Akil?
Yes, sir.
The only thing is we don't know what the number is to multiply by. Right? For now. We don't know where it is for now. But we know that SX supposed to be equal to something, right? Some number multiplied by RS. So the next thing I would tell you to do is, well, I would ask you to put down what RS is. RS is 1/6B plus a third A. That's what RS is. So is there anything you can multiply this by to get back SX? So you look at the elements on the inside and you ask yourself, is there any number I could multiply by, to really get back SX? You see any number you can multiply by to get back SX?
Well, SX?
Yeah.
Oh, 2.
2. And just like that, you get your answer. So if you could say that SX is 2 times 1/6B plus a third A, which is RS, you can prove it. You prove that they're scalar multiples of each other.
Yep.
Yeah. So all these are just different ways you could work the same thing out. But one thing I'll tell you about your working, right? You don't just jump from this line to this line. You at least need to do the factorization part where you pull out something. Yeah. Understand? Or nah?
Yeah, understand.
Okay. Alexia, Kylie, Nikolai. Let me know if anything confusing earlier. If you have anything earlier, want me to go back or are you okay?
Say legal, sir.
Hi, good.
Okay, by the way, I should say in 1 hour is Tivon's birthday. So earlier, light up the group chat. Yeah.
What? Alright.
Right. But yeah, guys, I'll end it for tonight. I'll send all this in the group chat. If any of you on the TikTok and all you want to be in the Vibe Central group chat, just send my message on TikTok. I'll add you. But yeah, guys, it was nice seeing all you. I hope all you have a good night. Later, everybody.
Bye,
Yes,
sir.
sir.
Yeah,
Enjoy
sure.
the
Thanks for the help.
No problem.
Thank you.
So how to end this? Okay. Bye, guys.